In this episode of Trusting AI, Unlocking AI's Black Box, we delve into machine learning development and operations to see how trusted AI is used in production. Tommy Lee and Andrew Butler, software developers in IBM's Center for Open Source Data and AI Technologies, take us through the Fairness 360, Explainability 360, and Adversarial Robustness toolboxes.
Hi everyone, my name is Tommy, and I'm an open source developer working at IBM. Currently, I'm mostly working on an open source project called Kubeflow, which is an end-to-end machine learning platforms.
Hello everyone, I'm Andrew. I also work for IBM. I'm also working on the Kubeflow project, specifically KF serving, KFB Tekton, and I've also done a little bit of work in Trusted AI.
Today, I will going to show some of the trusted AI projects we're going to talk about. There's three main projects we are contributing to the LFAI foundations. One is the AI Fairness 360, which is responsible for checking whether the data and model are treating the prediction fairly. AI Explanations 360 is a library for explaining how the model get its predictions. And Adversarial Robustness Toolbox is responsible for adding a text to a model and verify whether the model is robust enough to defend against any inferior attacks. And we have all this trusted AI platform, which really helps to verify our model is good enough to be in productions. And to do that, we will use what we call Kubeflow pipelines and KF serving. Kubeflow pipeline is the end-to-end ML workflows that responsible for connecting all the workflow steps together. And it's a scalable cloud platform, so you could train, verify, and deploy models based on your environments and your scalabilities. And it's very extensible and pluggable, so you could plug any the AI trusted AI library we showed it before in here, and it's easy to verify the model is suitable for production or not. And from here, we'll go ahead and let Andrew to describe you what we're going to show for today's demo.
Sure, yeah. So here, I'll share my screen. Quickly revisiting. So basically, what we're going to be going over is a specific one in KF serving. This one is for artificial intelligence explainability, so the AIX tool. And so we're going to look at an example where we have a picture from MNIST, just a simple digit, and AIX is going to explain why one of the models that we've used previously and we've added into this explainer tool is predicting a certain number over another one, or why it's confident in this number versus another one. And that's specifically gonna use Lime for this demo, but there are a bunch of other tools in the toolbox that you could use in AIX to explain it and get different explanations that are maybe looking at different reasons. And then the next example that we have is for the Adversarial Robustness toolbox. And basically what this one's gonna do is just add some adversarial noise and try and get the model that we have deployed to predict it's the same data set in MNIST, but it's going to try and make the model mispredict the sample that it's given. And it'll just do, there's a number of different ways, just like in the AIX, but this one's going to be using the fast gradient sign method. And so let's take a look. So the way it works specifically is we have in KF serving deployed an inference service, and so that will host both the model and then the explainer. And so I've already hosted those or deployed those so that we can take a look at them. So let's look at how we're going to query them. So we're just going to pick an image. It's the image we saw before, and just wrap it and load it to send as a payload. And then we're going to send that inference request or send the request to the inference service, and then unwrap the results and take a look at it. So let's see what that looks like. I have it already set up. You can see here that let's see, once it loads, that I already have 2 inference services set up, one for our AIX example and one for our ARC example. And so now we're just going to query those specifically. Let's start with the AIX. So what we've just done here is we're looking at what we've done here, and then we're going to query specifically the inference service that we had talked about previously over here. And then that'll take a second, but it'll give us the results that we see below here, and then I'll explain a little bit about what they're supposed to tell us and what it means. And these can take varying amounts of times, but Lime and this one is specifically supposed to go a little bit faster for demo purposes. But so here we have this image, and this first example shows what pixels that it has chosen, and those are highlighted in red, that seem to designate that in actuality this number is a 2. And so you can see it selected all of the pixels. And so the way this works is it takes a certain confidence score for each pixel, and if it's above that confidence score, then it shades it red. And so you can see this one, most of the pixels, or if not all the pixels, have been selected. And this is, so for 9, it doesn't really think any of the pixels it's very confident in show that it is a 9. And this is a combination of each specific pixel and the pixels around it. So it gives you somewhat an idea. And so it does this for all the numbers. And this basically shows that for 8, it says, hey, these pixels make it seem like it's an 8. So it selected some of them, but not all of them, as we've seen in 2. And so that's part of the reason why it selected 2 over 8. And you can do the same thing for any of them. So that is for the Artificial Intelligence Explainability Toolkit. And now looking at the Adversarial Robustness Toolbox, we're going to do a very similar thing. We have an inference service propped up, as I showed before. We're going to take this original image, wrap it up in a payload, and send it to the inference service. And what we're hoping to get back is a slightly changed image that has this noise on it, and will make our model predict something else. So now we'll send a request for that. I've already had it set up, so it's querying the inference service we have. And so these are the image. This is the original image, and then this is what it looks like afterwards, after our adversarial robustness toolbox has worked on it. And you can see that there's an amount of random pixels that have been, I mean, they're not random, they're specifically chosen, but they look random and they've been added around to kind of trick the model. And so in this example, our model has predicted 1, as we've shown above. But for this example, any human would be able to tell that it's a 1, but our model has mislabeled it as a 7. And so that's an example of what you can do with the adversarial robustness toolbox and the artificial intelligence explainability toolkit. And I'm going to pass it over back to Tommy, and Tommy's going to show you about some things in Kubeflow pipelines and the AI fairness project.
Right, thanks, Andrew. So I'm going to show how you use AIF 360 in terms of chaos serving. So over here in this case, I will describe in high level. So for the actual models and the explanation, they are all in like separate containers. So you could provide any model that has several feature inputs and outputs, and you could just plug in and extend without modifying any like monitoring code that we have provided to you. And this is very nice. So you could just like code a model with a certain way, and basically you just get the free functionality to see whether your model is fair or not. And when you're going to like deploy these models, we are going to ask you like several information, such as what kind of feature you want to use. In this case, we're using like German credit data sets. So we are providing a set of information such as age, sex, credit history, and based on that, we either like approve or deny a credit card approval based on those informations. And once you provide those, we will have a model deploy. So we are going to go ahead and deploy AIF 360 models. And once the model deploys, you're able to see the model and the explainer is deployed on a Kubernetes cluster, and along with the URL that we turn from that services. And once we have that services, we can just go ahead and plug that in here along with a certain payload you want to like check for fairness. So over here, we will provide a set of test data for verifying how fair, how the model is doing against this like tested data. So we're going to send this batch payload. And once we send it, we will be able to see this batch payload is returned with a base rate of 92%. So it's pretty consistent as well with 98% consistency. However, you could see like the disparate impacts where the number of unprivileged that is returned positive over like the number of privileged group returned positive is pretty low. So that means like if you're in the privileged group, you're having a highest chance to get approved for the credit cards. So you could see like this model is not performing very well, and from here we could go ahead and apply any additional processing to the data set and make it more fair before we put it in productions. And now what we show you is like how you do it in black box. But if you are able to like put everything in the pipelines, you can also like run these trusted AI library in a white box manner, and you get more metrics by doing that ways. So here we're going to show you how to leverage Kubeflow pipelines to train the models and then verify whether the model is robust enough and fair enough to put in productions. So you basically just like load some of our predefined components that we hosted on GitHub, and then just run this pipeline with the parameter you have inputted for the model code, what model you're going to train. We're using like a 3-layer CNN to train like visual recognition models. And once we train the models, we're going to see like a set of fairness metric and robustness metrics. And based on that, we could see like what area we need to improve in terms of fairness and what kind of area we need to improve in terms of robustness. So once you execute the pipeline, you should be able to see a pipeline links provided by the Jupyter Notebook. And behind the scene, you would take a training platform in Kubeflow called Katav. You can also leverage distributed training with Katav and train the models. And once the model is trained, it could store in object storage and let the trusted AI platform to take over the model and do some white box metrics verifications. Since this model we're going to take 10 minutes to train, so I already have something have been pre-done. So once the model is trained, and you could pass in like 2 different libraries. One is for Adversarial Robustness Toolbox, and one is for AIF 360. And for the 360, you could able to see like the output is actually stored in object storage, and you will get a much more details metrics in terms of like things like false negative and false positive rate, where you cannot do it in a black box manner because we don't have the original data set. And also with Adversarial, you're able to get more metrics on the accuracy overall and how much perturbation is made on these particular models. And with this, that's the end of our demos. Thank you very much.